Now we will see the Dijkstra algorithm. Dijkstra algorithm is used to find the shortest path between the two mentioned vertices of a graph by applying the greedy algorithm as the basis of principle. This algorithm can work on both directed and undirected graphs. Now we will see the code. Import required library. The heap queue library is imported for priority queue functionality, allowing efficient retrieval of the vertex with the smallest distance. Dijkstra algorithm function. The Dijkstra function takes a graph and a starting vertex as inputs. It initializes a priority queue with the starting vertex and sets initialized distances to infinity for all the vertices, except for the starting vertex, which is set to 0. Process the queue. In a loop, the algorithm poops the vertex with the smallest distance from the priority queue. If a shorter path to the vertex has already been found, it skips further processing. Explore neighbors. For each neighbor of the current vertex, the algorithm calculates the distance through the current vertex. If this new distance is shorter than the recorded distance, it updates the shortest distance and pushes the neighbor onto the priority queue. Build the graph. The build graph function promotes the user to input vertices and edges, constructing a graph represented as a dictionary where each vertex maps to its neighbors and edge weights. Now we will see the main execution. In the main block, the graph is built from the user input and the starting node is specified. The Dijkstra function is called to compute and print the shortest distances from the starting node to all other vertices. Now we will see the execution. Enter the vertices and then enter the number of edges. Then enter each edge as start, end and wait node. Enter the start node to execute the code. Then it will give the short distances from the start node.